All right, 8th grade. We're going to go back in the book now and pick up a few of the little things you're going to need later on in your algebra toolbox here to do well in the future. One of these things is lesson 87 called factoring by grouping. It's when you got to factor a quadrinomial, 4 terms, all right? 4 terms instead of 3, all right? And this is something that will come in handy. It is not something you're going to need to do when you go to Kroger and keep your social distancing, but as you will see perhaps even in the next lesson, this ability to turn an addition problem into a multiplication problem comes in very, very handy. Now we start with something very simple here. We got a quadrinomial, yes. Just because it doesn't have fancy x's and y's and exponents and so forth. This is still 4 terms, all right? And if we were to do this, we would simply add the terms because they're all like each other, right? 2 plus 4 is 6, plus 7 is 13, plus 14. We could add all this up and get 27, and that's how we would do it. We would never factor out by grouping. However, I do want to show this to you how it works, because if it works with numbers, it works for letters too. All right. So the whole idea of factor by grouping is to put the quadrinomial into 2 groups, and each of the 2 groups has a GCF. All right. In other words, I make a group out of 2 plus 4, and I make a group out of 7 plus 4. With me so far. And I notice that 2 and 4 have a GCF. So from this binomial, I'm going to factor out the GCF, 2. And that would leave me with 1 plus 2, right? Distributive property, yeah, I'd be back to where I started from. And here, I see the GCF is 7, so I can factor out a 7 and get 7, that would be 1 plus 2. All right? Now here's where factor by grouping comes in. Notice that this factor, this chunk, is a factor, it's being multiplied, and this factor are common to both the 7 and the 2. So that makes 1 plus 2, in parentheses, the GCF. And I can factor out the GCF. I don't have to write it twice. I can write it once as a multiplication problem. 1 plus 2 times what's left, 2 plus 7. And that is the result we're looking for when we factor by grouping. Now we want to get even, you want to prove it, we can FOIL this, right? First times first, 2. Inner plus 4. Outer plus 7. And last times last plus 7. And we would get 7. And, 14, not 7. Last times last is 14. And, 2 plus 4 plus 7 plus 14. Or, 1 plus 2 is 3. 2 plus 7 is 9. 3 times 9, 27. You get the same answer here, all right? Except now we have taken this quadrinomial with 4 terms, an addition problem, and written it as a multiplication of binomials, all right? And you would never do that with numbers. You would just add the numbers. They're like terms, right? Likewise in algebra, if you got like terms, you're going to combine them, make your life easier. But life often doesn't give you like terms that you can add together, all right? These are not like terms. None of them can be combined with any of them. So what we want to do is be a little more clever and say, well, can I factor by grouping? In other words, can I take and recognize these have some common factors here, and these have some common factors there. And so I'm going to group them with parentheses. And now just looking at the ones in parentheses, I'm going to factor out the GCF. In this case, for numbers, 2. Most x's I can get is 1, x. And y is not a common factor, so that leaves me with just x plus 2y. All right, and I quickly check my work, distributive property. Yeah, okay. And now I look at this and I say, well, what's the GCF there? Well, it's just a 7. So I'll factor out a 7 and get x plus 2y. Oh, coincidence or not? X plus 2y is common to both, which makes it the GCF of this whole thing. And so now I can write this as simply x plus 2y times 2x plus 7. And we're done. Does that make sense? Well, you're right, it does get a little more complicated. All right, sometimes we have to rearrange things. We're given this, and we go, yeah, that's got y's that are common, but that would leave me with something here that doesn't even have a GCF, right? If I group this and group that, that would be a problem because this doesn't have a GCF. So let's rearrange them. I mean, these are just terms that we can rearrange using the commutative property of addition, right? So I'm going to rearrange this one over with this one because 3's are common. And then I've got a minus 3y squared, or to the third, minus 3x. So I just kind of rearrange that. I just kind of move the plus 3 over. And now I can group this, and I can group that, all right? And now GCF here, factor out a 3, I get y squared plus 1, minus, I can factor out an 8, and get y, actually I can factor out an 8y, that's even better, yeah. Which gives me y squared minus 1, all right? And I look at this and I go, wow, y squared minus 1 and y squared plus 1 are almost alike. Almost. And here's where you can do a little thing called changing the sign, right? I mean, what would happen if we were to change the sign of this to be a plus sign? And have plus 8y. And now, this would be minus y minus y squared plus 1. All right. And that would give me the thing that I need there, y squared plus 1. And so I get my common factors, and away I go. 3 plus xy, y squared plus 1. Yeah. All right. So basically we're just factoring GCFs. If I got something here, whatever it is, doesn't matter, and something here, whatever it is, but it's the same. By factoring out, we only write it once and then combine what's left. All right? You've been doing that since 6th grade when you've been combining like terms. 2a plus 4a is 6a. A is the common factor. I could factor it out, all right, and get a 2 plus 4, all right? And 2 plus 4 is 6, and a times 6 is 6a. This is why exponents don't change when you combine like terms, all right? A stays a because it's a common factor. I haven't multiplied it by anything to change the exponent, all right? So we're doing pretty much the same thing there, all right? Now, back to this idea of using opposites, all right? Here, we start off with that already grouped, factored out, all right? And I've got AB minus 6 plus 5 times 6 minus AB. Again, almost there. So I can change the sign here, which will change the sign here. Minus 5 times AB gives me minus 5AB, and this would be minus 6. And I wind up with the same thing I had before. Minus 5 distributed, minus 5AB, minus 5 minus 6 plus 30. All right? So if you change this sign, you can change both signs inside the parentheses. That's the trick called using opposites. Because now I have a common factor, AB minus 6, AB minus 6. And so AB minus 6 is 1 term, and that's going to be times 3a, but now it's minus 5. And again, if you were to FOIL this, you would come up with what you started with, which is how you basically check your work, all right? So let's try that one more time, all right? Here I've got a quadrinomial, I've grouped it. We can pull out the GCFs here, 6 and an x and z squared are all the greatest common factors there. That leaves me with 9z plus xz squared 1 there. Again, distributive property gets me back to where I started. Minus, and now 2, 9, z squared here. It gives me 9z minus 1. And once again, gosh, we're very, very close, right? 9z and plus 1, 9z minus 1, all right? So we've got 6xz squared, 9z plus 1. If I change the sign, all right, then I change the sign inside as well, 9z plus 1, all right? And yeah, notice that this minus sign got distributed. Yeah, I could do, yeah, and then either way. It gives me the common factor here, all right, which is what we're after. So that we get 6xz squared plus 2z squared as one term, and the other term is the 9z plus 1 for the answer, all right? All right. Lesson 87 also talks about doing factor by grouping with trinomials. Don't bother, all right? Unfoil is much, much simpler. So for lesson 87, simply give this a try on these 4 quadrinomials, A to D, and that should do it.